What is RoPE? RoPE, or rotary positional embedding, is a method widely used today to help transformer models better understand the position of each word in a long sentence. In traditional positional embeddings, like sinusoidal embeddings, we add a position vector to each word. The downside is that we have to store these positions explicitly. With RoPE, things work differently. Instead of storing positions, RoPE rotates each word's vector according to its position. This allows the model to figure out relative positions naturally without keeping track of them separately. Why is this important? First, it lets the model capture relative positions naturally during self-attention. Second, it works well with very long sequences, even without fixed-length embeddings. Third, it preserves the original embedding magnitude, so it doesn't interfere with the word vectors. Finally, it can handle sequences longer than what the model was trained on. In short, RoPE provides a simple yet powerful way for transformers to understand word positions efficiently without extra storage or fixed-length limits. How does it work? To understand the concept better, let's take an example using a 2D vector case with the sentence, "Dog is slowly chasing a cat." First, the tokenizer takes the word dog and converts it into a token ID, in this case 101. Next, the embedding layer turns this token ID into a base vector. At this stage, the vector for dog might be roughly similar to cat, but quite different from other words. Then, the transformer adjusts these vectors using the sentence context. For example, in dog is slowly chasing a cat, the model understands that both dog and cat are animals involved in the same action. As a result, the vector for cat moves closer to dog because the context highlights their relationship. Finally, RoPE adds positional information to each vector. This helps the attention mechanism understand which words are near or far from each other, so the model can focus on the right words in the sentence. As a result, the transformer gives something like 0.9, 0.1 for dog. RoPE helps provide rotary position info of other words relative to dog. As you can see, cat ends up closest to dog. This means the attention weight is no longer just about the content of words, but also about their relative positions. When cat moves closer to dog after RoPE, it's because the rotation increases their dot product, giving dog more reason to attend strongly to cat, even if they are far apart in the sentence. Furthermore, when the dog vector is rotated, the relative dimensions are preserved. Small changes in positional rotation correspond to close relative distances, no matter the absolute positions. In 2D, changing the dog vector's position causes it to rotate, preserving its relative angle to other vectors. In higher dimensions, exact angles may change, but the relative relationships along each dimension are preserved. That's how RoPE helps transformers keep word meanings intact while adding just enough positional info so the model knows not only what the words are, but also where they are in the sentence. Thanks for watching. I hope this video was a helpful step in your AI journey. If you found it valuable, feel free to like and subscribe so that you can be notified of any upcoming videos. Thanks for joining me today.